Good morning, everybody. I'll get us started this morning. My name is Megan Skelton. I'm a part of the National Accounts team here at Wolseley, and I'd like to introduce a few of my colleagues. So we have our dealer development team here as well. I believe only Jill or Joanne is on at the top right now, but Craig and Jill will be joining us. Also today presenting, we have Craig Anderson, who is our lead TSA of Ontario Atlantic. And we should have Thyra Sager joining us shortly from ICP as our ICP Regional Business Manager. Just a couple of housekeeping rules. We will be recording this session, so if you could just to be aware of that. And if you have any questions, feel free to either raise your hand or use the message comment box, and we will answer those at the end of the session. And just keep your microphones on mute should you for this presentation. So I will hand this over to Craig now, and he'll kick us off today.
Morning, everybody. Thanks for coming out. So today we've been asked to get everybody refreshed on AC season. AC season's it's on its way, hopefully. Weather's starting to get a little nicer, so we're just going to give everybody a little bit of a refreshment of what we need to remember our practices and what kind of tools, a little bit of troubleshooting, some wiring. Will be about 45 minutes to an hour today, and then we'll get you on your way. So if you haven't met me, my name is Craig Anderson. I work for Wolseley. I help lead up the technical service division within Wolseley, the TSA program. So within this program, I'm happy to announce that we now have 3 full-time TSAs within Ontario. We're working on a 4th to get us into the 4 corners of Ontario. We also help out the Atlantic a little bit when needed to help them troubleshoot as well. So as of right now, we have myself that's full-time. We have Guy Denis down in Thunder Bay that's full-time, and Steve Martindale has just joined us out of the GTA area. So he will be full-time. And we also have part-time TSAs, and we call them part-time because they're working a branch as well. So altogether, there's 3 of us that are full-time, and total with all our TSAs, we have 9 TSAs within Ontario that can be reached out to help troubleshoot if these guys need any help. So like I said, today's just going to be a refresher on some AC stuff and some troubleshooting, some wiring, so we're ready to go when the season hits. So I always like to start it off with this website. This is our go-to website. So there's gokeepright.com. If you've never been there, get on there, browse around, spec sheets, installation manuals, technical manuals, anything you need if you're on site, if the wiring diagram is not on that piece of the unit anymore. You can pull it up on your phone right on gokeepright.com. There's no passwords needed to access this account. Just go to the gokeepright.com and you'll get into this website right here. If you've been on the website before and you haven't been on it in a while, you'll notice it is a little bit different looking. They spruced it up again for you. So your main little box is going to be this search box right here. This is going to get you to any manuals that you want. So less is better. Usually about 4 to 5 of the first letters of the model number will get you to where you have to go. If we put too much, then you're just getting a whole bunch of nuisance stuff, or you're not getting anything at all. So if it's going to be for an air conditioner N4A3, that's all you need. You don't need the size or anything like that. So once you pull that up, it's going to give you the owner's manual. It's going to give you the installation manual, and it's going to give you the technical manual where you can find wiring diagrams, trouble flow charts, anything like that. So if you call any one of the TSAs and you're working on a unit, this is the website he goes to. He needs to see the wiring diagram and the troubleshooting flow charts and stuff like that. So this is the real perfect site for you guys when you're on a job site, or if you're in the shop, if you're going to be installing something new that you haven't installed before, get on here, look at what you're going to be installing or what you're going to be going to service. If you haven't serviced that unit before, everyone's a little bit different. Good site to go on to just to refresh your memory on some stuff. So I'll just go up through product lines so you have an idea of when you're out there what you're looking at, or if you guys are doing sales as well, stuff you can look at. So AC product line, we got a variety, entry level, performance level, 13 SEER to 16 SEER ACs, coming with the R4A3s to the NXA6. All have scroll compressors, 10-year parts warranty if the customer registers it. So that is a very important point on any Keypright product. You need to register it to get the 10-year warranty. We run into it a lot. Customer thinks they have a 10-year warranty. Customer didn't register it. Contractor never registered it. You're only getting a 5-year. So make sure your customer is registering it, or register it yourself for the customer. You know it's done. So the next one is the upscale unit, a little better cabinet. Some of these have 2-speed fan motors on them. 13 SEER to 19 SEER on these units with communicating capability as well. So this is the communicating modulating AC that you guys will be installing or have installed already. So this unit is 5-stage modulating, as long as we're putting it on with a communicating furnace and a communicating stat. Everything needs to be communicating for this unit to be a modulating unit or a 5-stage unit. This unit can also be installed on a 2-stage gas furnace, wiring up to standard terminals, Y1, Y2, or RNRC to our outdoor unit. We can make this unit a 2-stage as well. Very nice unit, nice and quiet. It has the variable speed compressor, variable speed fan, high-low pressure switches also. This one backs itself up with a 10-year no hassle unit replacement if we have a compressor failure or an outdoor coil leak. So good to know on a 10-year no hassle for that unit as well. But fully communicating with a fully communicating indoor unit and thermostat. We also have offered out there is a 2-stage 17 SEER. This can be wired as communicating or a non-communicating unit as well. This unit here, if we're doing communicating, only requires a 2-wire outside. So if you're looking at a unit change out and you only have 2 wires, you can go to a CCA 7, 2 wires to the outdoor unit. We can make that unit communicating as well. CSA 6, this is a single stage communicating unit with the ion control, or if we have an older observer control, it will be compatible with that too. So this is another option for communicating. If you don't want to go communicating, we can wire this up as a non-communicating AC as well. This one's backing itself up with a 5-year no hassle replacement warranty. So the higher tier units, your CSA 6s, your C4A3s, CCA 7s, you'll notice those will have a little bit better warranty. They're backing themselves up with a no hassle. Some have the 10-year, 5-year, and some have a 1-year no hassle replacement. So just for out there if you're selling. So C4A3 is the bottom tier of the nicer looking unit. Some of them come with a 2-speed fan motor outside, compressor sound jackets, high-low pressure switches, stuff like that. If you're going to service it, you know what you're getting into. NXA6 is the 16 SEER, down and dirty AC. We sell quite a few of these. 5-year warranty out of the box, 10-year if we register it as well. Copeland compressors on those as well, but nice 16 SEER low-end model if you're looking for something. N4H4A, so this is our side discharge unit. So for install purposes, we can get up to 250 feet of line length on this. So if we're doing condos, stuff like that, very nice unit, quiet. The funny thing is on this is when guys install these for the first time, I usually get a phone call. The fan motor on these, the way they're designed, this fan motor is designed to turn backwards. And it's a blow-through design on these units, the way they're manufactured. So I always get a call on a guy that's always installed it for the first time. He's been working on it for a half an hour. He's not sure what's going on. The fan motor has been turning backwards. They are designed to turn backwards. So if you do install one for the first time, just be mindful that, yeah, that fan motor is going to turn backwards. But nice unit. We can get up to 250 feet. Same thing as the other ones. If we register it, 10-year warranty. Performance Series N4A3 air conditioner, down and dirty air conditioner, dual compressor like the rest of them, 10-year warranty if we register them as well. So evaporator coils, we have a good line of evaporator coils through ICP. We have this horizontal cabinet. We have a slab horizontal coil as well, upflow case coil. We also have the A coils and we have the N coils. There's a new one that's coming out that you'll probably see in the near future. Will be another case coil that they're coming out with, and they call it the V coil. So in the case, you'll notice when these come out that it's an A coil, but it's upside down. So it's designed for superior airflow. We're getting better airflow once it's going through the V out of the case. As of right now, they're only going to be offered in case and not to an add-on like the N coil. So that'll be coming out in the near future. So for airflow purposes on older oil furnaces and stuff like that with belted motors, and we're worried about airflow, that coil will be coming out in the near future. But we have a variety of the coils now, A coils, N coils, all that stuff. So I like to go through the N coil. I get a call probably a dozen times a year that the air conditioner's freezing outside. Pressures are good. I leave, it's freezing up. So we have to be very mindful of the N coil because of airflow. The N coil underneath has two openings. It has an opening where the A part is on the coil. And then on the right-hand side where the N part goes on the coil, there's an opening under there too. That opening's about 1.5 inches. And a lot of the times, if the guy's not familiar with the N coil, he is installing it like he's installed an A coil. Putting the channels on the side, 1.5 inch, 2-inch channels, screwing them to the plenum, sliding the coil in. So what's happening is they are blocking off the right part of the coil fully, or they're blocking it half off. So be very mindful of that coil when you're installing it, that you're not blocking off the right-hand side of that coil. So if you'll notice in the bottom part of this picture is a plate. So this plate is actually attached to the coil when you take it out of the box. Take that plate off the coil. That is your template. When you take it out of the coil, you can turn it upside down and sit the coil on top of it inside the plenum, or you can keep it the same way that you took it off the coil and install it that way. So once you install that plate and screw it in with your angles and everything, as long as that whole opening is open in that plate, then you're fine when you sit your A coil on it. So it's a great template, especially if you're using channels. Put your channels in, set this plate on top, make sure that right-hand side is not blocked. If that right-hand side is blocked, You're going to start your air conditioner. It's going to run for 15 or 20 minutes. Everything's going to look hunky-dory. You're going to put your tools away. You're going to wave to the customer and you're going to leave the yard. That afternoon, they're going to call you because that air conditioner is frozen up. It will slowly freeze the right-hand side of that coil till the whole coil is frozen. So if you're running into cases like that on service calls, you didn't install the coil, always get in there and check that out. It'll solve you a lot of headaches. I've been to a lot of job sites where that right-hand side of the coil was blocked. Service tools. So let's get out in our trucks. Let's make sure everything's working. You're going to start getting into air conditioning. You're going to start using your tools. Make sure your tools are working. They're oiled. They're ready to go. So manifold gauges, combination manifold gauges should never be interchanged between different freons. Different freons have different oils. Different oils break down other oils. So if you're working with R22, you're working with 410, 404A, have a set of gauges ready for each unit. If you're working on air conditioning mini splits, you're going to be a 410A gauge, and you're going to need adapters for the end of your gauges to go on to the valves on a mini split because they're a 5/16 flare. Check out your gauges. Make sure the oil rings are good. Lube them up a little bit with some synthetic oil. Get them ready. These seals will dry out. It will cause your vacuum not to pull a vacuum if you're leaking out of your gauges and that. Make sure your hoses are good. They're not cracked and they're ready to go. Cutting tools. Make sure your cutting tools are clean. They're not rusted. Your wheel's going to cut right. We have a deburring tool. Deburring's a major thing when we're coming into mini splits. We want to make sure that we're deburring that copper before we're putting a flare on that. If we're not deburring it, what it's doing is giving us a double flare when we're putting a flare on that unit. When it's flaring down, it's giving it a double flare. So make sure you're deburring the tool, the copper. Make sure when you're deburring the copper that you're putting the copper down and the metal flakes are not going back into the tubing. I've seen it, guy standing there doing a deburring tool and all the filings are going back into the copper. So once those filings are in the copper and you start that unit, it starts flowing, especially when we get into mini splits. We have strainers and everything that are in the system. The copper is so small, it doesn't take much to block a 1/4-inch copper tube. So just be mindful when you're deburring it, you're deburring it good. If you don't deburr your copper on a standard air conditioner, you could get some noise with the freon going through the pipes. It's not flowing properly. We're getting some restriction. It does sometimes create some noise. So make sure you're deburring it and your cutters and all that are sharp and ready to go. You're not mushing the copper and stuff like that. Vacuum pumps. Make sure you have a minimum capacity of a 6 CFM vacuum pump. Make sure you're not using a vacuum pump that's too big. A vacuum pump that's too big, like 12 CFMs or bigger, what you're doing is you're pulling a vacuum too quick. If you're pulling the vacuum too quick, so what happens inside the unit, that moisture that you're trying to get out, you're pulling it out so quick that it actually freezes. And when it freezes, you pull your vacuum, you release your freon, that freezing now melts. Now we have moisture in the system. So this is why we're going to go through a vacuum process to make sure that you're doing it properly. So make sure your vacuum pump is working. It has a built-in check valve. Some of the older vacuums don't have a built-in check valve. And what happens if you're not sitting there and watching the unit and the vacuum turns off, if there's no check valve in there, now your vacuum is under a negative pressure. So when it turns off, it's going to suck whatever it can from wherever. So we could actually get the AEC that's under a negative pressure to be pulling whatever's in that vacuum pump out. So make sure it's got a built-in check valve. Make sure you're changing the oil regularly. I'm not saying change it every time you use the unit, but change it regularly. On new installs, not too bad. We're dealing with new copper. We're only dealing with new equipment. If you're doing a lot of retrofits, you'll notice your vacuums take longer. It's taking longer to take the moisture out. So what happens to the oil is you're taking the moisture out of the system, it's going in the oil. So if your oil has too much moisture, it's going to take you a long time to pull a vacuum, or it's not going to pull a vacuum. So that could give you an idea of saying, okay, well, I'm not pulling a vacuum. Maybe I have a leak. No, maybe it's the oil that's in your vacuum. It's diluted so much that it can't take any more moisture. So make sure you're changing the oil frequently on it. Required installation service tools. So mini splits, you'll notice all mini splits have flare nuts on them. So make sure that your flaring tool is a 45-degree 410A rated flare tool. There are different flaring tools that will not give you a 45-degree. So if you bought one at Canadian Tire or Princess Auto, take a look at it. Make sure that it's rated for 410A, and it'll do a 45-degree flare. 45-degree flares are a little deeper to get that sealed on the flare nut. Digital vacuum gauge. Make sure your vacuum gauge is working. If it's a type that needs to be calibrated or it has a date on it, get it in there and get it calibrated. If it needs a new sensor on it, order up a new sensor. This is the only way we know that we have the moisture out of the system. The R22 days are gone. Watching your gauge, leaving the vacuum pump on for a half an hour, 20 minutes, that's not telling us if the moisture's out of the system. The only way to do it is with a digital vacuum gauge. All kinds of people make them, Yellow Jacket, UEI, anywhere. Make sure you have one. It's the only way to determine time, and looking at your gauges is not going to do that. Scale. If you don't have a scale in your truck, you're not installing an air conditioner properly. Every truck should have a scale, whether you're a service guy or you're an install guy. If you're working on an air conditioner, you want to weigh in your gas. We're dealing with variable speed compressors. We're dealing with two-stage compressors. We have no idea what stage that variable speed compressor is in. So really looking at your gauges is not telling you what's going on. All it's telling you is you have gas in the system and your compressor is running. If you don't know what stage it is, you really have no idea what your pressure reading should be at that point. So if you're doing a new install or you're working on a unit where you doubt what the last guy did or what the guy put in and took out, take the gas out and weigh it in. It's the only proper way to do the system. If you weigh the gas in to the factory charge, add your gas in to what the unit recommends for the longer line length, that is out of the equation. I have the right amount of gas in. Let's move on. Let's check airflow. Let's check something out. Take the time, weigh the gas in, take it out of the equation, move on to what's going on next. A couple other tools nice to have. Nitrogen purge tool. It hooks up to your nitrogen tank. It has two settings. It has purge and it has like a weld setting. So once you put it to that weld setting, it will only allow enough nitrogen to go through your lines. So when you're doing your brazing, we want nitrogen going through our lines because we want to get the crap that's inside that lines not to form. If you're not running the nitrogen through and you're welding your line, it will make little flakes inside the copper. Those little flakes are going to go into your TX valve. They're going to go into your strainers on your mini split. So make sure you have a nice purge tool. You don't have to play with the regulator that's on the bottom. As long as you have 50 PSI of gas in it, this will regulate what you need to go through it. So there's no setting, just turn the nitrogen tank on and away you go. Nice little tool. So installation tools for you that are out there. We have benders, spring benders. We have the Ritchie crank benders. We have Allen keys, and then you'll have your service wrench up here in the right corner. Service wrench is great for doing your valves outside. I recommend you take your Allen key first, get it in there, do your first little crack with your Allen key, and then putting your service wrench on it. The service wrenches tend not to get into that service valve deep enough all the time. Sometimes it gets in deep enough. It all depends on the mold of that valve. If it doesn't get in deep enough, there's a 75% chance that you're going to strip that valve. Get in there with a standard Allen key, get your first crank, then get your service valve in there, and then open up the rest. It's going to save you a lot of headache down the road. If you strip that service valve, it ain't fun to change. Other tools that you should have in your truck, refrigerant leak detector, if you're a service guy, probably a good thing to have if you got that stubborn leak you can't find. Clamp on meter to do your DC voltage, your AC voltage, your capacitor checks, a nice multimeter that does everything. Couple pocket thermometers, don't just buy one, buy two. We'll go through that later. Manometer to check your static pressure in your ductwork. That's critical nowadays, which we'll go through coming up. So just some tools that you should have. If you don't have, good idea to get. Digital vacuum gauge, scale. This little setup up in the corner, this is called a Hub 6. This is made by UEI. If you're looking to buy yourself a little Christmas gift or a birthday gift, and you do a lot of service on air conditioners, this is a Cat's Meow. It has 2 clamp-on meters to go on your liquid and suction pipes outside. The center is your gauges. You're not dealing with the round gauges that are bouncing around, and the hoses are not. This is just screwing on to your high and low side. You have 2 pocket, I'll call them pocket thermometers, or thermometers that'll go in your supply and return. This attaches to your phone via Bluetooth. It's going to give you everything you need on that air conditioner. It's going to give you superheat, subcool. It's going to tell you your return air and supply air temperature. It's going to tell you the temperature of your liquid line and your suction line. It tells you everything. If you add a smidgen of gas, it's going to tell you on your phone what has changed. If the unit is running outside and you're playing with airflows inside to see what's going on, to raise your low side or whatever you're doing, checking filters, you could be inside looking at your phone instead of going outside. Okay, let's go outside and see what that unit's doing now. Great investment if that's something that you like, the techie stuff. If you're getting into the trade and you're going to be planning on staying in the trade, great add-on to your toolbox. And that's through UEI. It's called the Hub 6. So good practice for piping as well. A lot of guys do a lot of new constructions. They get their install crew out there, slam in 6 units, and then they go back and install the air conditioner outside. Like we talked about before, we're dealing with 3/8 lines, 1/4 inch lines. Any blockage in those lines could do a lot of damage to the air conditioner, and it could do a lot of hunting. And what I mean by hunting is your air conditioner freons are going to hunt for different flows if we're working with TX valves and stuff like that. So any little bit of dirt that gets in our strainers or screens and everything could throw the whole game off for you if you're out there servicing. So let's get away from capping the line, taping the line. That can fall off. Seen it on job sites many a times. Back when I was in the trade, we used to cap it and we used to tape it. When we went back, that tape was nowhere to be found, or that cap was nowhere to be found. There was cement, stucco, all that sitting on the pipes. So just be mindful when you're running your lines, crimp them off. We're talking about pinching them off and brazing them in here. If you don't have your tools to braze it, at least pinch it off. That is going to solve a lot of the problems down the road. Install guy gets back, throws the air conditioner on. We have no idea what we've put in that line. So just pinch it off. Just be mindful if you're running the line before that air conditioner is going in. So good practices, as I talked earlier on your welding, always run dry nitrogen through the line. Pull your Schrader valves out, your valve cores, get those out. You can put a wet rag on your service valves outside if you'd like. There's a nice little Viper wet rag is out there. It's reusable. The container is about $35. It's probably going to last you a year, depending on how many air conditioners you do in a year, but standard year, this will last you. For $35, it's reusable. We just keep it moist. You bunch that up around the service valve or wherever you're welding, it stops the heat from going in there. You overheat the service valve, you're going to have a hard time opening it. If you're using the ratchet wrench to open it, then this is where we're getting into stripping that valve. We've overheated it. We're not using the proper Allen key to open it up. So get yourself some of this heat block putty. It's fantastic. Wet rags do work, but you notice yourself if you put a wet rag on there and we got some extreme heat on there, that rag is pretty hot after you're done. This stuff here eliminates the heat from getting to that valve. Take the valve cores off, run dry nitrogen through. We're keeping the lines nice and clean, and we're drying them out as well when we're using the nitrogen. Just be mindful when we're doing those service valves. So making a good 410A flare, what we talked about before, good flaring tool. Make sure that our cutters did a great cut. We've deburred the copper, no filings are in. Get your flare nut on there, get your flaring tool, make a nice flare. We don't want any sealant on that flare. Sealant, if it gets into the system, it could make up a mess. It gets hard like bubble gum. It gets stuck to the side of the refrigeration line. It's restricting the flow of the Freon going through the line, especially when we're in modulation on these compressors and EE valves. Little restrictions make a lot of headache for the service guy that's going to the next. So make sure you got a good flare, you've deburred it, and you're ready to go. So when we're doing a flare connection, in the manual, it'll actually tell you what the torque capacity is on that flare nut. A wrench on each side, so we're not twisting the copper, we're not changing that copper from round to oval. If we're changing it from round to oval or we're twisting it, then we're changing the inside diameter of that copper, which we don't want to do. So always use a backup wrench. If the flare nut's a little tight, take some synthetic oil, put it on the copper so that flare nut will turn a little bit better. Do not put it on the flare fitting itself. If we're getting oils where the flare nut is connecting to the flare fitting, then we could get it loose a little bit. So make sure that's dry so we're getting a brass to brass connection. Once that's tight and it's torqued, it should not leak as long as we have a good flare. Do not go out and get a bigger wrench. It's not solving the problem. It's actually creating more of a problem. It's probably going to mushroom your flare or it's going to crack the flare nut. You should not need a lot of force to do a 410A flare with a couple Crescent wrenches and a torque wrench. Leak check. We call it a 3-step leak check. It's always been out there. It's always been in the manuals. What we want to do is we want to do a 3-stage. First thing it's going to do is going to save you nitrogen out there in the field. If you got a leak, crank it up to 100 PSI, hold it for 5 minutes. If it moves within that 5 minutes on 100 PSI, then you know you have your leak. If you threw the whole 600 PSI in there, then now if you have a leak, you just lost all that nitrogen. Throw 100 in, wait for 5 minutes, bring it up to 300, wait for another 5 minutes. If it doesn't move, then crank it right up to 600. These units can operate up to 500 PSI before the actual compressor will go out on an internal overload or a high pressure. The compressor will shut off, but they can get up to this pressure. So let's test it at that pressure. Let's make sure it can run at that pressure and we have no leaks. So do a 3-step, save yourself some nitrogen, 100 PSI for 5 minutes, and then boost it up to 600 PSI and hold it there for an hour. So required practices if you're leak checking. We don't recommend household soap. We don't know what's in there, and if it does get in the lines, we don't know what kind of damage it's going to do with the internal oil. So there is commercial leak detection spray out there or soap that you can use that's rated for refrigeration use. Buy the right stuff, use that to do your leak stuff. Standard air conditioners, they have no problem recommending leak dye refrigerant or sealant in their systems. The only time you do not want to use that in a system is when you start getting into variable speed air conditioners or mini splits. They do not recommend any leak detection or leak sealant in those systems. Because there's EE valves, which is the valve that modulates the freon going to the indoor unit, that little valve can move 480 positions. There's strainers on it. We can't have anything that will slow that EE valve down or gum it up or anything like that. So anything that has variable speed, so variable speed air conditioners, or you get into your mini splits, do not use your dye or your refrigerant leak sealant. Standard air conditioners we're okay with. So system evacuation, this is the big thing. This is where we want to get the moisture out of the system. 3-step evacuation, it's been in the manuals for years. This is nothing new. This is what they've always recommended. We're trying to dry what's in the system. If that is dry and we got pure freon going through it, then our system is not contaminated. So what we want to do is we want to bring our vacuum gauge down to 4,000 microns. We want to hold it for 15 minutes. Then we want to break it with dry nitrogen. So we're drying the line a little bit more, getting more moisture out of it. Bring your vacuum down to another 1,500 microns. Hold it for 15 minutes. Break it with a dry nitrogen again. We're drying it some more. Throw it on again, bring it down to 500 microns and hold it under 500 microns. And when I mean hold it under 500 microns, you're turning the vacuum up, pump off, you're isolating your gauges. You'll notice your digital vacuum gauge will rise because if you're doing a new install, it's very easy to bring it down to 78 microns. The hard part is holding it there. So once you've done your evacuation, you've turned everything on, watch your micron gauge. It'll move up. Once it moves up, it should stabilize. And when we want it to stabilize, we want it to stabilize under 500 and we want it to hold there. If it doesn't hold there, then there's two things going on. You have moisture still in the line or you have a leak. Get it under 500, hold it there. We know we have the moisture out of the line. So a little troubleshooting AC units. I always start with the contactor. I get calls every year on it. I have 220 to the outdoor unit and 24 volts. Contactors pulled in and the air conditioner is not running. So 24 volts each side of the contactor when we're testing it, 220 volts from L1 to L2. So when we're testing your L1 to L2, we're putting our multimeter on L1 and L2 to get our 220 volts. Some panels will allow you to put a breaker in, and it'll only take it off one leg of the panel. So always check between L1, L2. If you run into a panel like that and you're checking your voltage outside, if you go ground to L1 and ground to L2, you'll get 110 volts on each side. But when you go across your L1 and L2, you'll get 0 volts. I get calls on it every year. So always check your L1 to L2 when you're doing your 24 volts or your 220 volts to make sure you have power there. If you're going L1 to ground, L2 to ground, getting 110, then you're going across the L1 to L2 and you're getting 0. Something is going on elsewhere. You're not getting your proper power to your outdoor unit. Capacitors, big thing. When I actually worked in the branch, we sold a lot of capacitors. When we get a heat wave, they usually blow up. You open the panel inside of the air conditioner, you're doing a service call, and this thing's a mushroom or a balloon. It's blown up. Easy service call. I'll go get a capacitor. Easiest thing to get out of the way if you have a multimeter, check your capacitor. The fan motor's not running, the compressor's not running. Test it with your multimeter. There were so many capacitors that used to come to our counter and they were fine. We'd sell the person the new capacitor because they wanted it. They'd throw the other one in the garbage. I used to reach out of the garbage, put it on the counter and test it with my amp probe. There was nothing wrong with it. Use your testers. Very easy to test. We're testing the capacity. You can do, they have actual meters that just do that, or most of your multimeters do it now. So this one has your compressor and your fan built in. It's a dual capacitor. One will say Herm, one will say fan, and then your common. If you're going from your common to your Herm or common to your fan to do your testing. Fan's usually about 5 or 7.5, depending on the rating. And then your Herm runs from 25 to 45, depending on the size of the unit outside. So always check your capacitor. Testing a compressor. You've got power to the compressor, everything else is running, the fan motor's running. So we want to check the windings. So we want to do a resistance check reading on the compressor to see if the winding is damaged. So easy little test. You can I suggest testing it on the compressor. You can test the wires first before you take everything apart and get to the compressor, but always a good idea to test it right on the compressor. So if you go from your R to your C, and then you go from your S to your C, and you add those together, they should equal your R to your S. If it doesn't equal, then we have something going on internal with the winding. So one, you could, it might say OL, you're not getting any reading, then we know right away that there's something going on. We should have resistance between those windings, and they should add up to your R and your S. If they don't, then we have some winding damage. If your R to your C or your S to your C are open circuits, and your R to your S has resistance, then you have an internal overload that's open in the system. So what I mean by your internal overload, if you get to a job site, everything's working and the compressor's not coming on, turn it off. If you can reach in there and touch your compressor, if you can barely touch that compressor, it's so hot, then chances are the internal overload is gone on that unit, or it's open. So you need to wait till it cools down. So you have two options at that point. You can try pouring some water on it to cool that compressor down to see if we can get that overload to go back to normal. Or you're going to look at the customer and you're going to say, I'm going to see you later this afternoon, or I'm going to see you tomorrow, because that unit needs to cool down to see if that overload goes back. If the overload doesn't go back, then we have a damaged compressor and it needs to be changed. This is a great thing to have in your truck. If you don't have one, it's a hard start kit. Beginning of the season, this compressor has not done anything for 6 or 7 months. It's sitting there, the unit's old. Sometimes it needs a little get up and go. If you get to a unit, the unit turns on, compressor turns on, then it clicks off. Let's try one of these. You can save the person a lot of money. Put it on. If it works, leave it on. Could give them another 2 or 3 years out of that compressor. It's just giving it a little get up and go to get moving. Great thing to have in your truck. They're like $35. They could save you, customer, a lot of money and save you a lot of time. 24-volt wiring. So you're going to get into 2-stage air conditioners. You're going to be working on heat pumps as well. Not really a heat pump. We're getting into cooling season, but be mindful of what you're testing outside. 2-stage air conditioners. L1, L2 is your 24 volts for your staging outside. R and C, depending on the unit outside, you might not have an R, but you'll have C out there for your common. So heat pump wiring. So now you're going to be looking at the heat pump is now switching over into cooling mode. So be mindful of what you're going to be testing outside. Most reversing valves are energized in the cooling mode. So be mindful that you're going to have 24 volts on your O now. We want to energize that reversing valve. We want to change the flow of the Freon going through that heat pump. Heat pumps are designed on a split system to, if the reversing valve failed or something failed, they will still have heat. So when we go into air conditioning, we're always going to be energizing our O for our reversing valve. And then we're going to be energizing our Ys, depending on what stage of cooling that you're going to be asking for. So 24 volts to your outdoor unit on those connections in cooling mode. If you're working on communicating systems, a little bit different. We're checking RNC. RNC is our voltage that are going to our outdoor unit or to our thermostat. Typical communicating wiring is 4 wires outside, depending on the unit. Some of them are only 2 wires. Look at your schematics that are on that unit for that unit. And then 4 wires to our indoor unit via a green plug to connect the units to the board downstairs. If you're working on a communicating unit, and the outdoor unit is not communicating, we can connect that to our board downstairs. We're not going to be using the green plug. We're going to go right to our board on our furnace. So if you're adding on an air conditioner that is non-communicating to a communicating system, you are going to go back up to that stat and you're going to have to relearn that stat. And by relearning that stat is going to allow the stat to look for equipment again, because it wasn't programmed into that stat. So make sure after you do an install on a communicating stat that you'll have to go back to that stat and let it know it has an air conditioner now. If you don't, the air conditioner just won't start because it doesn't know it's there. So if you're working on a communicating system that has communicating stat and a communicating indoor unit, and the customer has an existing heat pump or 2-stage air conditioner and they want to keep it, we can hook it up to a communicating system, but we have to add a communicating relay. When we get into a heat pump or a 2-stage AC, we have to add another computer board to a furnace in that state. So if you're working on something as well and you get their communicating system inside, non-communicating system outside, chances are there's another communicating relay that's hooked up to that furnace that you might need to check for voltage signals and stuff. Fan coils are a little bit different. We don't need to add a communicating relay into them. Most fan controls, their control board will take a heat pump or a two-stage air conditioner. The fan coil is designed for heat pump application most of the time. If we're putting a fan coil with electric heat, chances are that unit is just going to be strictly AC only, or we're putting a heat pump on it. So that board is already wired for a non-communicating outdoor unit. Room sensors are a great thing too if you're running into issues with that hallway's always hot, or we're into a commercial unit. When we get to an ion stat or an observer stat, we can add multiple sensors to it, so it will take the average of that room. So if it's in a small commercial place and someone's always hot, someone's always cold, you can put multiple sensors in that area, or you could even do it in a house if you'd like. If there's the double floors and stuff like that, what it'll do is it'll take an average of those 4 sensors to heat and cool the space. So great little add-on if you're running into a house that, oh, this room's always cold or this one's always hot. You might be able to throw, if you have a communicating system, a bunch of sensors in that area, and then it'll take the average of all to try to satisfy everybody. So nice little add-on for the ion stat and the communicating systems. So we got everything done. Our vacuum's done. Our test is done. Our wiring's done. We're ready to go. You're ready to start the unit and get off to the next 2 that your boss has booked in for you that day. So this is where you want to do your readings. You don't want to just throw your gauges on and allow yourself to maybe get in, we'll say trouble the next time. Write down what you're doing. If you don't have an evaluation sheet made up, make one up. Write down what your pressures are. Write down the temperature it was outside that day, what your supplier temperature. Mark down all your readings. So if something does go on and the next guy goes in, then you could leave it there with the job, take a picture of it on your phone, make another copy when you get back to the office. So you just have a track of, this is what I've done and this is what's going on. So always record it, whether it's an air conditioner or gas furnace, what your readings were. So you know next time you go, this is what I had this time, what's changed. So basic review. We have an evaporator, we have a compressor, we have a condenser, and we have a metering device. This is what all we need to make the system work. Outdoor unit, indoor unit, thermostat. All these are going to make this unit operate. Big thing nowadays, if you guys are not doing it, start doing it, whether it's an air conditioner or it's a gas furnace. Always check your static pressure. You're dealing with ECM motors that are looking for static pressure that is going to ramp up and ramp down. So always check your static pressure. It's going to tell you also if your filter's bad, your ductwork's bad, your coil's blocked. We need to make sure that we're getting the proper airflow. If you're getting the proper airflow, static pressure is built into the furnace. It's going to tell you on the side of the furnace on the rating plate what your static pressure should be for that unit. 0.5 to 0.8 inches water column is fantastic. And that's the reading most of them you'll see out there. If you're getting up over the 0.8, if you're getting into 1.2s, 1.4s, you have ductwork problems, or you have a blocked coil, or you have a filter issue. The motor is going to die. If you're going through motor failures on a furnace constantly, or high limit problems in the winter time, and now we're having freeze up coils in the summertime. Check your static pressure. If that is on, then we're taking that out of the equation. Our airflow is good. We need to look at fan speeds. We need to look at something outside the box. So two main things: static pressure. Make sure you got the proper charge in your system. Great two things to get out of the equation. Static pressure takes nothing to check. Get the proper instrument, throw it in the supply and the return, let the unit run 15 minutes. Let's see if our airflow is good. Temperature rise, same thing, whether it's in heating or cooling. Let's see what our split is between our return air and our supply air. That could save us heat exchangers down the road. That could change us, save us freeze up in coils. It's going to tell us what's going on in that ductwork. If the ductwork's proper, not enough registers, not enough return air. Pull that pleated filter out of the cabinet. Pleated filters are horrible right now. If you're working with a pleated filter, that's the 4-inch or 5-inch with the back cabinets. Fantastic. Upsell your customer on that. Get away from the 1-inch 3M pleated filters. They're causing havoc on high limits, and they're going to cause havoc on your air conditioning system coming up. I don't know what they're making them out of right now, but they're like cardboard. Heating season was horrible for pleated filters. High limits, day in, day out. Changing temperature rises 15 to 30 degrees on a brand new 3M filter out of the package. So be mindful when your air conditioning comes up, what kind of filter they have in there. Get a box of 12 of disposable filters, not the pleated ones, just the cheapies. Carry them in the truck. Trust me, you're going to use them. So airflow is good. AC is ready to go. We've weighed our charge in because that's the proper way to do it. Now we're going to start the unit. We want to make sure that we know what we have inside. So we have TX valves on coils, or we have piston metering devices. So this is metering the freon that is going to the system. So we have to be mindful of what you have out there so we know what we're checking outside when we get the system going. So metering device, refrigerant flow control, that's what it's doing. Meters refrigerant into the evaporator coil, whether it's through a piston or whether it's through a TX. Creates a pressure drop needed to lower the saturation temperature, the boiling point of the refrigerant. So when it hits the coil, it's changing state. So two basic types. The top one, we have our piston that's inside our coil, or we have a TX valve inside our coil. If you're working on a heat pumps are generally going to have a TX inside, but be mindful of some heat pumps that are outside. Some heat pumps outside will be monitored through a piston, and some will be monitored through a TX valve as well. So be mindful of what's in each outdoor and indoor unit when you're doing your test. So thermal expansion valve, the ability to respond to the change in the load. So it's responding to the change of the load to maintain a proper superheat on your suction pressure. So it's taking your suction line temperature to change that TX valve, whether it's opening or closing, to put the freon through your lines. Typical hookup, your blue, your yellow, your red. Your yellow's going to your charging tank. Blue's going to the larger one, which is your suction line, and red's going to your liquid line, which is the smaller one. Typical thermometer locations when we're doing our startup. We're going to check the airflow, the temperature that's going into the coil. Just make sure you're not in the sunlight so it's getting a proper reading. Clamp-on meters are perfect. We want to clamp onto our liquid line and our suction line when we're doing our testing. So charging a fixed metering device system by superheat. So that's your piston. Superheat while you're checking your saturation temperature, which we'll go through. Your subcooling and your indoor temperature drop, so that you're split between your return and the supply. Charging with a TX valve by subcooling while you're checking your saturation temperature, your superheat as well, and your indoor split. So we're wanting to check all this stuff once you get that unit running. So calculating operating superheat. So identify the evaporated suction temperature, determine the refrigerant type that you're using, and the saturation temperature. So on your gauges, on your low side, you'll have the pressure that's on the outside, which is your PSI. And then inside your gauges will tell you the different freons, whatever you're working on that day with your gauges, will tell you saturation temperature. So measure the suction line temperature with an electronic thermostat. Clamp on is always better. Hook it up to your meter, or if you have a special thermometer that will clamp onto the pipe. You could use a pocket thermometer to get you through, shove it through the insulation. We want to get a reading on that pipe. Clamp on gets a better firm fit on there. So attach it securely to the suction line outside of the condensing unit. So to calculate your superheat, subtract your evaporator temperature on your low side of your gauge from your suction line surface temperature obtained to obtain your superheat. So suction line surface temperature, that's on your clamp-on probe, and then you're going to get your saturation temperature. So subtract the two is going to tell us your superheat of that unit. Pretty easy. As long as you have the tools, measure the temperature, look at your gauge, subtract, that's going to give us our superheat. So TX systems are designed to regulate a constant superheat. The required superheat should remain fairly constant. 10 to 15 degrees is the normal factory setting for TX valves. Fixed metering device, allowable tolerance, and it's always an allowable tolerance within our industry, plus or minus 5%. However, we always recommend to go on the plus side instead of the negative side. So refer to your charging charts. They're in the manual, they're on the unit. Subcooling is only as a checkpoint for fixed metering devices. TX valves is the primary method. So you need to know what you have inside so you can determine what you're checking outside. We always check both, but the one that's for that metering device is the one that we want to concentrate on. So calculating your saturation temperature, again, on your high side gauge. Identify the condenser saturation temperature on the inner dial. Like I said, on the low side gauge, same thing as on your high side. Use your clamp on meter, clamp it onto your high side gauge now, and we're doing the same procedure. We're subtracting one from the other. Condensing saturation temperature minus your liquid line temperature is going to give us your subcooling for that unit. So always go to the charts that's in your manual, your PT charts, see what your split is inside, compare all the readings to make sure that you're operating properly. That's what I have today for everybody. Your biggest thing is out there, we're getting into air conditioning season, make sure all your tools are working. You have the proper tools. Like I said, static pressure is our biggest concern out there. Airflow on your air conditioning system, if you have that down and you have your charge weight in, that stuff's out of the equation. Let's figure out what else is going on. So very easy steps to eliminate a lot of hassle down the road. And that's all I have for today, everybody.
Thank you very much, Craig, for everything today. I'll open up to questions at this time. Okay, if there's no questions, this concludes today's session. I want to thank you again for joining. I know this isn't always the easiest way or the best way to do training. Hopefully, our next round will be in person with everybody. Have a great day. Actually, there is one question in the chat now. What method do you use to determine metering device in plenum?
Repeat that, please.
What method do you use to determine metering device in plenum?
Well, the metering device is going to be attached to your coil. So each manufacturer has a different way of putting their metering device in. So for a piston, it's going to be a piston in the coil. If we go with ICP coils, the metering device is already attached to the coil in the location where they want it. Goodman and ADP, they have different applications for their metering device. Some of them think it should be outside the airflow on the suction line. And if you put it outside the airflow on the suction line, then what you want to do is you want to wrap that with Armaflex and make sure it's strapped on there perfect, so that bulb is not being affected by outside airflow.
Sorry, Craig. Just to further that, Charlie has put in the chat, looking at plenum, cannot determine what's inside, i.e. cut in loose A coil.
Oh, if you're not sure if what's in there, then we're doing both readings outside. You're going to do your subcooling and you're going to do your superheat. Both methods are once a checkpoint when you're doing your subcooling. We always want to check your superheat too to make sure it's in that area. So if you're checking both, you need to check both anyways. So that's going to determine if one is way off, then we know probably what's inside the coil. But the best thing is to access it to see what you're playing with to get the proper reading for sure.
Charlie, does that answer your question? Okay, perfect. And then the other question from Charlie was if the C4A3 is available. Specifically have it on my list. Do you know, Craig, if they're bringing those into inventory?
The C4A3.
Yeah.
I know it's still available through ICPs from the last time I checked, but I believe corporate or somebody has. I think we're up to the CSA5. I believe is the replacement for that unit.
Okay, yeah, because that's the one that they use commonly as CSA5. I didn't recognize the C4A3, and I don't see it on our master price document either. So I was curious about that.
Yeah. I think it was a corporate decision between stuff that's coming up and stuff that will probably be nil and gone, because we're going to see 13 SEER just kind of slowly dissipate as we did. Heat pumps we're up to 15 SEER that we get. So you'll see that with air conditioners too. The 13 SEER will be going away, and then we'll be up to the 15 SEER on air conditioners again.
Okay, perfect. All right, if there's no more questions, we'll close this off.
Thanks for your time there today, guys. Appreciate it.
Thanks, Jeff.
Yeah, thanks, Craig. Thanks, Megan, for setting this up.
It's perfect. Thanks for everybody for coming.
Have a great rest of your day, everybody.
You too.
Bye-bye.